So Godot uses what we call a scene. A scene is basically a tree of nodes. Each node has other nodes as children. It's like a little tree. Any node can have other nodes as children. There's always one root of the whole scene tree, and every node has a function, something they do specifically, right? So nodes have names, and they have properties, and they have a predefined function. Here are like examples of like a sprite, something that plays music, something that gives you physics. This is like a skeleton, like a 3D skeleton, something that shows text. And you can also put logic on the nodes. You can put a script so that you can, have behavior, have a logic. So here's an example, right? How do we use nodes to represent a game? So if you have a windmill, you're gonna have the blades on the sort of base of the building. These are going to be meshes, like a 3D mesh. Then you have collision, like a static body, some collision shapes. Then you have some animations maybe to rotate the blades, and sound, maybe some particle effects, maybe stuff like that. And you're gonna have behavior, like the windmill. Maybe you want to change the speed depending on the wind, or you want to do, I don't know, maybe it does something. Maybe it's an RTS game, and this windmill outputs things like flour for your army or something. And so, we make a little tree with all of these nodes, and we have a root, and then we use all these types of a 3D mesh, collision nodes, sound, and some scripts. Now, if we have a farm, we're gonna have a bunch of this part it's in Spanish. These are windmills, and these are the nodes of the windmill. So if you have a farm, you're gonna have many windmills, and then you're gonna have like the ground, and also maybe you have a town, and you're gonna have many houses, right? So we need to reuse this scene, this windmill scene. So what we do is we can instance the scenes inside other scenes. So it's just like a node can have other children as nodes. We instance scenes inside other scenes, which is simply like to instance to make the root of the node, of the windmill node, we make it a child of one of the other nodes, and that's it. It's like a, infinite depth. And we simply pick a node to say this node is the root of something that I consider to be the windmill, for example, right? Or this is a house, this is a whatever. Everything we get to decide really what is the abstraction level, because the scene is just a bunch of nodes. It doesn't really care. It's a little tree of nodes. So instancing, it lets you organize the content and reuse it, and we're going to go into all the advantages of it. So here's an example for a 2D scene. We have a root scene, a root node, with a sprite and some collision and like a sound node. And so the root is a rigid body for physics, has a sprite as a child, collision shape, and it can play sounds, and it has the script on the root. So for 2D scenes, we have a node 2D, which is a base type of like all the 2D nodes. They will inherit the node 2D type. They're blue on the editor, and they have like inheritance of the transform. The transform is like the position, the rotation, and the scale. So basically, when you move the root node, the player node, you also move all the children. So it behaves like some sort of object, right? Like in my backpack, I have a bunch of things inside. When I move my backpack, I'm moving everything that's inside the backpack, right? Something like that. This is kind of how we abstract things in the world. Like I carry my backpack, I get on the bus, and the bus driver drives the bus. He doesn't care about the stuff inside my backpack because like things contain other things, and this is how we think of the kind of how we organize all the things we have. We're gonna go a bit more into that also, and so there's a bunch of types of 2D nodes. We have the engine has a 2D space separate from the 3D space. So the node 2D nodes, they have a position in the 2D space. For 3D, it's a similar situation. The spatial node is the root of all the 3D nodes. They have position in 3D space. They're red usually in the editor, and it's the same. When you move one node, all the children move with it. All the children that have that are in the same 3D space, and we have all the types of 3D nodes: particles, mesh, lights, cameras, etc. Right, and 3D physics. And so here's a little scene too. Cube with some lights and a camera. Oh, hold on. Okay, so these two are in Spanish. I apologize. But this is the same as the two previous types. So we have the UI, all the UI controls to make like the user interface in your game. They are part of the scene too, and so there's a control type of node, and it's the same. The UI shares the 2D space with the 2D nodes, right? Because it's part of the 2D space, and so all the UI controls that you use, they inherit from the control type. And when you use the engine editor, the Godot Engine editor, it's actually running on top of Godot Engine, and it's using all of the UI elements from the engine to sort of create. So the Godot editor is kind of like a Godot game running on top of its own runtime. And oh yeah, this one is Spanish too, sorry. But there's a bunch of nodes that are sort of generic types of node that don't have a position in the 2D or 3D space, and they do things for us that are just in general. For example, animation nodes. There's the stream player nodes, the sound, the nodes that play sounds that are not positional sounds, because we have positional, like 2D positional and 3D positional sound, but you can also have like just the background sound, and so that one doesn't have a position, and so there's just generic types, right? And so we have there's a bunch of like a timer, for example. A timer node is a node that will wait for some time and then shoot a signal, something like that. There's a bunch of helper nodes like that. And animations are yellow, but I don't know what color. They're usually kind of this gray color or white, I guess. So here's a bit of a comparison. Nowadays, I hear that some other engines have like nested prefabs. So this may be an old comparison, but yeah, usually you'll see like a scene with a lot of prefabs all on the same level. And so in Godot, we have this kind of nested hierarchy. And so it lets us sort of organize the scene and collaborate with people. prototype at different levels. And so the biggest point here is that because we have different scenes that are, they can be instanced in many levels of depth, then we can let people in the team work at these different levels of depth. And so we can let the level designer doesn't care about the specifics of like your windmill scene, right? They care about placing all the windmills in the terrain. And then the programmer is working inside of a scene, maybe in those specifics, and then different artists can work at different levels or can work at separately on different objects. Maybe like you have a terrain with a house, and inside the house there's a table with some glasses, and so each member of the team can work at each different level of the scene, and they can also not care about the other levels, right? And that's something that goes with the previous example of like the bus driver who drives a bus. He doesn't care about what's on my backpack, right? I have to worry about that, but only when I pack my backpack. Then I take my backpack and I'm just thinking about where did I put my backpack, that sort of thing. And so this is it's kind of something that we don't realize, but this is how we sort of think about this is how we think of the world generally. So here's an example. This is like a 2D game, and we have, for example, all the coins, all the platforms, all the enemies, and in this case we organize this like we just put all the coins inside one parent that has all the coins, and the same with the enemies and the props, and then there's music. And so, for example, here you see a node with the player up there, and so this player node, you see it as just one node, but in reality it's like an instance of the player scene. And if you go inside the player scene, there's a bunch of things, but again, like the level designer doesn't care on this screen. You don't really care what's inside the player. You just want to put the player wherever they need to be, or where they need to spawn, something like that. And so we sort of see the player as a node at this abstraction level, and then we can go inside the player if we click on this folder icon next to it, and we can go inside and we can start editing that scene, like, and maybe we want to change, I don't know, the particle system when you shoot or something. And then someone else cares about that. We don't, or the game designer doesn't care. So basically we abstract all the parts of the game as scenes, right? So so we have a stage with an enemy, we have a ship, we have a weapon. The weapon will shoot bullets, and so we over there the bullets, we instance them with code, and we just add them to the scene, and they add them to the stage, maybe, yeah. And a missile, the same. Market, yeah. The HUD, usually we put it on the player, but sometimes on the stage, and so on. So everything, including the UI, it scenes. And you can do this on like a huge world, right? And so here you have that example, like maybe you have the terrain with like a house and a room and a table and a vase, or like the player with the hat, and so on, right? And so each different member of the team, they can worry about these different levels, and they can work together. It's easier to work together that way. because you don't really clash, or you clash. There's less clashing with other people when everything is at the same level. So now this is how we organize the space, but now we need it to sort of come alive, right? Scenes are static, except for like physics. All the scenes are just going to be there statically, and so we need to put a behavior to them. And so this is why we have scripting, right? And so all nodes, any node can have a script. Any node that in your scene can have a script, and the script will give it behavior. But also we have animations. Animation in Godot is very powerful because the animation can animate every property of a node. There's a bit more ahead, but basically it's not just the position or the frame of the sprite. It's also everything, like the modulation color, or I don't know, if you have, like, for example, some gameplay parameters, like does it take damage or doesn't take damage, you can change that on the timeline of the animation. You can play sounds from the animation, you can play particle systems. Anything can change on the timeline of the animation. So the animation player can animate all the properties of the node, can be auto-played or played from scripts, and there's interpolation for all data types. So, for example, if you have two positions on the timeline, the animation player will interpolate between those two positions, so your node moves sort of smoothly, unless you want it to sort of teleport, and then you can say, this is a discrete value. Like, you can say these two values are discrete, and so your node would sort of teleport to the new position. And so here you can see in the example, when you are editing the animation, these are the properties of the sprite, and you can see a key shows up next to all the properties. And so this key lets you basically put keyframes on the animation, and it's showing up on all the properties. So, for example, the modulation color, you can animate that. You can change the frame on the sprite. You can even change the sprite itself, the texture on the sprite, and just anything. You can also make the sort of cutout animation type of style of animation, where you have a big, here's an example of like a character that has like a big tree of nodes, and then each node is like a part of the character, right? Like a little skeleton in 2D. We have a 2D skeleton node also with bones, where you can put sprites and move the bones. But you can combine this with like sprite animation. So, for example, the legs here, the legs are nodes, and so you can rotate them and move them. But the face is a sprite with multiple frames. So you can change the frame and then change the movement of the legs. You can shoot particles from these jetpacks. This is an alpaca with jetpacks, by the way. And so you can shoot particles from the animation. You can rotate. This is like it's very complex skeleton, very lot of work, but you get a very nice kind of character, moves really well. We also have animation trees for 3D. So on 3D, you usually have, when you're working on a 3D character, you have situations where you have like a walk animation and a run animation, and you also have like, you have the gun like this, like your character has a gun, or maybe it doesn't, and you need to combine these states, right? So running with the gun, or running normally, or walking with the gun, or stuff like that. So here you have we have an animation tree, and this is similar to what you see in other engines, but basically you connect all of these boxes, you connect them, and then you have parameters, right? So here, for example, we have the idle animation and the walk cycle, and we blend them into one. And so the script will change the blend value between them. When you start walking, it goes to walk, and then when you stop, it goes to idle. And that's how you get a smooth sort of blending between two. And then you have things like the gun is over there, and all of that. Eventually you end up with a huge tree of things, and someone knows how to manage all of this, and so the scripting language of the engine is called GDScript. It's a typo here, Python. It's similar to Python. It's made for Godot specifically for a number of reasons. The main reasons were that we can run scripts on separate threads for things like background loading and stuff like that, maybe pathfinding, things like that. And also it's a scripting language. It's similar to Python, similar to Lua, all of these languages, but it has native types that are used for games. For example, 3D vectors, matrices, planes, things like that. That if you are integrating Lua, for example, into the game engine, you start like moving pointers around, like passing pointers around, and that's really bad for memory allocation. So this is better. And also, there's some advantages with memory allocation as well, in terms of like we use reference counting for objects instead of a garbage collector. And so it's a dynamic typed language, similar to Python or Lua. It's designed for Godot. It doesn't have any like crazy things. It's just, it looks like a normal language. I don't know. It's made to get people to learn it very quickly, because we know, like, a lot of people say, "Oh, a new language, what I have to learn." But programmers are used to learning new languages, so we know how it has to look, so that they say, "Yeah, I recognize this. This is," and they can start using it right away. Another factor in choosing a game engine for some companies, we hear from certain companies, we hear that they have a procedure to hire people, and so the HR person, they need to see like paperwork. Like if you claim that you are a programmer, you need to show papers that say that you're a programmer. So sometimes they'll say, if you have certification for the language that you use, that's better, because the guy can show the diploma for, I know C#, for example. And so we don't have certification for this. We do have a C# module that it's becoming, it's stable now, but for mobile, I don't know the situation. But this is the main language for the engine. It's integrated with the IDE in the editor, so we have things like code completion and nice syntax highlighting, stuff like that. So how does the script works with the engine is any node can have a script, and the script is basically the script is the node basically like so the script is a class, and all the functions in the script are methods, and they become methods of the node. So if you have the node and then you call a method on the node, you're calling a method from the script. or maybe you're calling a method from the native API of the node. It doesn't make a difference. It's like the script sort of complements the node in the most straightforward way possible. You don't need to think about how do I use the script, or how, you just use it. No need for global scope, because the scene is like a global. The scene, if you want a global thing, you put a global node on the scene, and so yeah. Okay, so that's an introduction. We're gonna do a workshop.